Today we talked about algebra and chemistry in this process. So let's move into some algebra and chemistry. First of all, understand that algebra and chemistry, we're going to be working with algebra all the way through chemistry. The chemistry is really, like I told you before, is a foreign language class, but guess what? It's also a math class. So you're going to be doing math. You'll want your calculator with you almost every single unit. We'll be doing a lot of math almost every single day in this class. And really, we're not going to get beyond pre-algebra. There's sometimes we'll go on to algebra and maybe we don't even get to the honors level algebra. It's just really more of an algebra or usually a pre-algebra level, but it is very, very important as we're going through problem solving. Now, there's two types of equations we have. First of all, the given equation. I will always provide for you the given equations, but what I'm going to teach you how to do, and this will be very, very valuable, it's going to pay off, especially if you continue to go on to physics, which those of you that want to go to a UC, physics are necessary, or actually is necessary. You'll want biology, chemistry, and physics. In physics, they'll teach you the same process, and that is to take your given equation, manipulate it for your unknown variable, and create what we call the working equation. So in that process, now in developing the working equation and we're isolating things, our simple fundamental rule comes into play is what we do to one side, we must also do to the other. So we saw this in some examples. For example, if I wanted to solve for x, and I have x plus y equals z, and I want x by itself, well, I'm going to subtract y from both sides. So what I do to one side, I also do to the other side. Next, I'm going to add y. So what I do to one side, I also do to the other side. Next, I'm going to subtract y and divide by 2. So in that process. So again, we're just, this is something fundamental. Make sure you understand it. We're going to be using this quite often as we go through this process. But really in chemistry, what the key aspect is we're going to be working with different equations. And so I will, like I told you, always provide you with the given equations. This is one of the given equations, which is density. Capital D is density equals lowercase m mass over capital V volume. So in this situation, if I wanted to find volume, I have my equation. Well, I want to get volume, I want to isolate it. Now this is very, very important you understand this, and this will save you a lot of time. Before you plug in numbers and muddy it up, and I know this seems kind of simple right now, but as the equations get larger, it's very valuable you learn the skill now. What I'm going to do is isolate my unknown variable. Here's a helpful trick. Any variable in my denominator. Now remember, on top, my mass, and top is my numerator, on the bottom is my denominator. Any variable in my denominator can trade places with the whole number on the other side. So basically, density and volume can just simply trade places. So it's like multiplying by volume and dividing by density. But why do that? You're going to get the same process. All you have to do is physically just switch them. You're done. Mass divided by density, you're done. Answer's done. Next, I know my density and I know my volume. Now I want to isolate mass. Now I understand pre-algebra wise to isolate mass. Now I'm going to multiply both sides by my volume. And so mass equals density times volume. E equals mc squared. We make it into Einstein's equation, but E is energy, m is mass, and c is the speed of light. Now what's very, very important here, first of all I want to isolate my c, so I divided both sides by mass, but now I realize I have to take the square root of both sides. What's very, very important here, which is not the same as your algebra or pre-algebra class, with that, whenever you take the square root of both sides, you would have put a plus or minus sign. We don't do that in chemistry, so you don't have to worry about that. We don't do that. We always assume it to be a positive value. Next one, PV equals nRT. This is the ideal gas law. We'll get into this one. I say in my volume, I want to get P, which is my pressure, to the opposite side. I'm going to simply divide. So this is working out this basically pre-algebra. Now I'm going to give you some geometric equations. These are always provided for you, so make sure you they're very helpful when you're doing homework, but on the test I'll always provide them for you. You do have to know what they stand for, however. Like first one, area of a square. You have the area of a rectangle. You have the area of a cylinder. A equals pi r squared. And then you have two circumference equations, both the same. Then you have density equals mass over volume. Then we drop down to volume equals side squared. That's the volume of a cube. The volume equals length times width times height is the volume of a rectangle. Volume equals 4/3 pi r cubed is the volume of a sphere. And volume equals pi r squared h is the volume of a cylinder. And so you do need to know these, what they represent, but the equations in and of themselves, I provide them for you. These are called given equations. Now, sometimes with your given equations, two given equations can be given in the same problem, and what you need to do is developing a working equation. You're going to blend those two working equations together by form of substitution. For example, in this problem, we know the density and the mass of an object, and you also know the radius, and you also know the height. Now, pi, we're just going to use a simple pi key. You don't have to equal 3.114, blah 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 blah. You're just going to use the simple pi key in your calculator, make it easy. But what we know here is we're talking about the same object. So whether it's the volume in my density equation or the volume in my cylinder equation, the volumes are both the same. So we're going to replace the volume with pi r squared h, carry out substitution. Now I have myself a working equation. Now remember, I'm solving for height. Now I see height is in the denominator, so I realize, oh yeah, height and density, the whole number, can just simply trade places. So before I plug numbers in, I just switch them. So now to solve it, all I have to do is take mass, divide by pi, divide by r squared, divide by density, and you're done. In this next situation, we know the density. We're solving for mass. We do know the volume. So what I'm going to do now is I'm actually going to first do this. Makes it a little easier. I'm going to first isolate my mass. Then I'm going to substitute in place of the volume the length, width, and height. So now my mass, all I have to do mathematically in my calculator, is density times length times width times height, and you're done.